The AI that we're training on the racetrack today will someday be life-saving technology on highways around the world.
From AgriPoint, this is Intelligent Everywhere. I'm James Kotecki. Today's guest is Paul Mitchell, CEO of the Indy Autonomous Challenge. That's self-driving race car competitions. Paul, welcome to the show. I want to start by asking, what is the AI that you're training on racetracks today? Like, what is the current state of autonomous racing?
When we first started the Indy Autonomous Challenge, the software and the algorithms that were being used to operate the race cars used some AI in the initial training, but they weren't nearly as AI as they are today. We used more traditional controls algorithms, but now with this emergence of physical AI, we are starting to see the different teams use things like neurosymbolic learning, using physics-based models that can only be processed with AI. And so we're beginning to see AI coming into this racing program, and it's exciting. It's a little bit scary because we're seeing testing that hasn't been done before, and you don't know whether this AI can handle the high speed environment of race cars. But it's a great proving ground because if AI can work at 200 miles an hour, it can probably work pretty well at 50 or 60 miles an hour.
These are race car competitions. You get teams of folks, I believe, from different universities around the
Correct.
world.
So we have 10 identical race cars. They're all IndyCar-style race cars, so the same race cars that are used in the Indy Next series. But instead of a human driver, inside the cockpit is robotics, hardware, actuators that can run the car completely autonomously. And then let's say the brain, the AI driver brain, is programmed by research university teams from top universities around the world. And they compete head to head in racing competitions at famous tracks. This is real race cars, but fully AI, fully self-driving technologies.
If I go to this race and I'm looking at these cars, is it possible I would confuse them for human drivers, even if I'm a real racing fan?
You would recognize that we're starting to clock laps that are competitive with human race car drivers. We are not necessarily going to beat the top human drivers in an IndyCar or Formula One car this year or next year, but I think it's not too far away that'll happen, certainly when it comes to single car laps. Where it gets really complicated is when you put more cars on the track. And we've just started to introduce multi-car, where we're up to 4 cars racing on the track at the same time. The AI driver's ability to navigate and track multiple cars around it and make decisions, not having any idea what the other cars are going to do is where you're really pushing the compute capacity and the capabilities of the technology.
Would an AI driver sometimes make moves or do things that seem unhuman or alien, but then actually, was the right thing to do for that situation? Do they ever look, different than human drivers?
The ability to run a car at the absolute edge of its vehicle dynamics capabilities is what race car drivers strive to do, but they doing that sort of calculating it by feel is what they say. In our case, we're calculating it based on science and physics. And so that is going to create scenarios where you might brake later than a human might brake. You might turn in a way that would have made the human driver very uncomfortable or feel unnatural. So the fact that there's not somebody in the cockpit at all means that the human element, which can include the feel and the sense and in some cases fear, it's just not there. If you can train it to drive as good as top human race car drivers, and then you put it into real world environments where there might be rain or fog or darkness or distractions or noise, none of those things are going to alter the AI driver's focus.
Tell me more about how this technology and these discoveries and innovations have transferred to regular drivers or will in the future.
Yeah, so actually earlier this year, Indy Autonomous Challenge created a commercial spin-out called Adaptation that is doing just that. So we're taking the hardware know-how and some software from some of our university partners, and we're testing it and developing software and hardware solutions for on-highway autonomy. And we've deployed it already with some Maseratis. So actually using electric Maseratis. What that demonstrates is that if we can get passenger vehicles to be able to manage what you call edge cases, right? Unknown situations on highways at highway speeds safely, right? Then that can really improve the commercialization of autonomous vehicles. And in particular, it can demonstrate how autonomous technology can be life-saving.
Are you working toward a future where it's mostly autonomous vehicles and people are not behind the wheel, or there are no steering wheels? Or are you working toward a future where they're still behind the wheel of a vehicle, whether that's autonomous for most of the time and then they take the wheel eventually? Just give me a sense of your vision of this future.
I don't think it's an either or situation. I think it's both. The technology that we're developing is important for both fully autonomous vehicles, what's sometimes called level 4, like what's happening with Waymo. Uh, and it's important for level 3, which is the sort of advanced driver assistance technology. If, in fact, there's a situation where the human cannot safely manage the vehicle, that at that point, the autonomous system should take over. So our technology is adaptable to both human-driven cars and fully autonomous vehicles, because it's really about managing the vehicle's dynamics at high-speed edge case scenarios. That's going to accelerate the pace of fully autonomous vehicle deployment because it makes it safe in kind of all driving conditions, and it can make human-driven cars safer.
What needs to come next for your work in autonomous racing, for this competition, and for maybe the broader project of autonomy and safety in vehicles to move forward?
First of all, I think that policy is going to be important, right? We can't have 10, 12 different markets for physical AI, whether it's autonomous vehicles or autonomous agricultural systems or drones. And so, having a patchwork of regulations where the US is doing something, China's doing something, Europe's doing something, Africa, Middle East, and it's all different is going to really slow the pace of market scaling. The other big breakthrough is an unknown, and it's a question of how much AI is going to be in autonomous and automated systems, meaning how much real-time decision making, real-time adjustments and learning can take place. And for this, I think we need to do more training, more development, more testing. For example, the use of synthetic data, right? It's very
Yeah.
hard to train AI in real world situations. So there's this emergence of synthetic data, which actually uses AI to
Yeah.
create unsafe situations or edge cases in simulation. And it's a bit of an unknown. How much will that synthetic data speed up the capabilities of the AI driving? And then the other thing I think is context training. I've been talking to some of our partners in the Middle East, and the driving behavior in the Middle East and in other parts of the world is different than it is in the United States or in Europe, and maybe even in different parts of Europe it might be different. As we train the software for on-highway driving, we may need to train it under different driving conditions in terms of how people behave on the road.
Paul, we've had a conversation as fast and as focused as an AI driver itself, but I want to give you the final word here.
The race cars are getting faster, the teams are getting better, the competition is rising, and we're really excited that our next race is going to be held the same weekend as the NTT IndyCar series. So we're finally seeing autonomous racing on the same race weekend as the fastest human-driven race cars in the world.
Well, thanks so much for sharing that with us, Paul. I really appreciate your time today, and thanks for coming on Intelligent Everywhere.
Thanks, James.
And thank you so much for watching. Please tell us what you're working on in the comments, and please like and subscribe and let the YouTube algorithm know that you want more Intelligent Everywhere from AgriPoints. I'm James Kotecki. Let's get out there.